Alright students, so today we're going to discuss the graphical representation of directly proportional relations. Now if you would turn to page number 6 of your books, we are basically going to take the example, the first one that we took in the beginning of the lesson, where we had the example of the library books being overdue and the fine accordingly. So if you remember that 1 day overdue cost a 15-cent fine, and then we were able to use that information and find out this equation. Okay? Now over here in table 1.3, they have taken out different values of y for different values of x. For example, if number of overdue days is 2, using the equation, they find out the value of y. Similarly, if the number of days overdue, which is x is equal to 6, they find out the value of y by substituting the value of x over here. Now, a few properties of graphs of directly proportional relations that you need to remember are given over here. That first, it's going to be a straight line. Secondly, it's going to be passing through the origin. Now, if you recall, we've already done graphs in grade 6. So we have the x and the y-axis over here. So that helps our a situation when we're using x and y as the variables that are directly proportional, as in this case. Okay? We have to set a scale. Now you can see over here the scale that they've set it on the x-axis. One big box is equal to 1 day overdue, and on the y-axis, one big box is equal to 15 cents. Okay? So they're plotting x-axis over here, the number of days, and on the y-axis, y is the fine in cents. Now over here, the table is given to you. You use these points and you plot the graph over here. Okay? I'll show you a couple of examples. For 1 day overdue, the value of y was 15. So this is our point, right? Now 2 days overdue, when x is equal to 2, the fine is 30 cents. So for 2, the fine is 30 cents. Then for 3, the fine was 3 times of that, 45. Now in the same way, our graph is going to continue like this, and you can see if we trace the points together, it's going to be a straight line, okay? And it's passing through the origin as well. Okay? Meaning, now if you can see that any variable y which is directly proportional to x, this can be written in the form of an equation using the proportionality constant k. Okay? Now, if any one of these values, for example, if x is equal to 0, and you substitute the value in the equation, y will also be 0. Similarly, if y is 0 and you substituted the value over here, x turns out to be 0 as well. Okay? So when we are drawing or when we are plotting the graph of a directly proportional relation, it will always go through the point of origin, because if one value is 0, if x is equal to 0, y will also be 0. Okay? So the two properties of the graphs of a directly proportional relation is, one, that it is a straight line, the same way as you did the linear equations in grade 6. And you know, in mathematics, a straight line means this or this, not necessarily just the horizontal and the vertical ones. Okay? But this is not a straight line. So the graph of two directly proportional quantities would be a straight line, and it will always pass through the origin. And origin is the point where both x and y are 0. Okay? Now, if you look at question number 10, on page number 11 of your chapter, exercise 1A. Now question number 10 is, y is directly proportional to x, okay? And y is equal to 20 when x is equal to 5. So y is equal to 20 when x is equal to 5. The first part is find an equation connecting x and y. Now we've done these questions in the beginning of this exercise. We have to find an equation connecting them. Okay? Whenever we need to find out an equation, we need to find out the value of the proportionality constant for this particular relation. Now y is directly proportional to x. It can be written in the form of an equation using the proportionality constant y is equal to kx. Now using the values of x and y that have been given to us already, y is 20 is equal to k times 5. So bringing 5 to this side, 20 over 5 is equal to k. So k is equal to 4. So now the value of the proportionality constant for this particular relation is 4. So when you write the equation that relates x and y, it will be, now you put the value of k in this equation, okay? So y is equal to 4x. This is the equation that you needed in part 1. Now part 2 is draw the graph of y against x. Now to draw the graph, the same way as we had done these in grade 6 as well, we have the equation given to us, this one. Now you keep putting in the values of x by yourself and you keep getting the values of y. Now we have x is equal to 5 given to us. So let's take the values of x as 0, 2 and 4. Not a lot of quantities, not a lot of values we need. Just a few, 2, 3 values, enough for us to be able to draw the graph. Okay? So now you substitute these 3 values. X is equal to 0. So y is equal to 4 times 0 in this equation. So y is equal to 0. See? The first point we get when x is equal to 0, y is also equal to 0. Now if x is equal to 2, y is equal to 4 times 2, which is 8. Now when x is equal to 4, y is equal to 4 times 4, which is equal to 16. So the second point we have over here is 2 and 8. The third one is 4 and 16. Okay? Now using these points, and you can use this one as well, 5 and 20, you can take the scale on the x-axis as one big box equal to 1 unit, and on the y, one big box equal to 5 units, or 4 actually, since they're all multiples of 4. ठीक है? ये आप scale लेंगे. Draw your x and y axis. This will be the x, this will be the y axis, and you're going to plot the points. ठीक है? This is how you're going to plot the graph in question number 10. And if you have any problems, you can message me and I can maybe help out with drawing one of the graphs, but it is exactly the same way as I showed you over here. Okay? For the value of x, you keep plotting the values of y. And still, if you feel there is any problem, you can use these solved examples to help you out as well. Okay? So today, we're going to do question number 10 and question number 11 as your homework.